Hello students, welcome to Basic Education. So today we have the grade 12 paper Mathematics P1 November 2024. The total marks of this paper is 150 and the time for this paper is 3 hours. Alright, so let's move to the first question. So question number 1 we have over here. So question number 1 having the 5 subparts, okay? 1.1 having 5 subparts. So first of all, we have solve for x. 1.1.1. We have to find out the value of x, okay? I'm solving this question. First of all, we have now 1.1, all right? X into x minus 3 equals to 0, all right? So this is a simple quadratic equation already factored, and we just need to find out the value of x from there. All right. So we have writing this x equals to 0 and x minus 3 equals to 0. Okay. So I'm just writing. So we have an x equals to 3. So the value of x we have x equals to 0 and x equals to 3. Now move to the next question, which is 1.1.2. We have this question, the 2x squared plus 1 equals to 4x, and we have to write correct to 2 decimal places, okay? So let's solve this question. We have a 2x squared minus 4x plus 1 equals to 0. I just take the 4x over here positive. When I take to its left side, it becomes negative, okay? So this is also, we have the quadratic equation, and you can use the equation be like that, okay? Minus plus minus b squared minus 4ac divided by 2a. As you know about that, this is the value of a, this is the value of b, and this is the value of c. All right. So I'm just putting the values in this question and we get the value of x. X equals to, we have minus into minus 4 plus minus 4 whole square minus 4 into 2 into 1, okay? Divided by 2 of 2, okay? So I'm just going to simplify this whole equation. We get 4 plus minus 16 minus 8 divided by 4, right? So it becomes plus minus 8 by 4. Now we have 4 plus minus 2 squared by 2 and 4. Now I'm taking 4 plus minus 2 into 2 by 4, okay? So you just simplify it a little bit more and you take 2 plus minus square root of 2 divided by 2. Alright? Now you have to simplify this equation for our positive and negative value. So when we have 2 plus square root of 2 divided by 2, and we have x equals to 2 minus square root of 2 divided by 2, right? So when you're solving this stuff, we have the value which is equals to 1.707, and when you're solving this question, we have the value is 0.2929, right? So we just have to place the values up to 2 decimals. So I'm writing here x equals to 1.71 and x equals to 0.29. All right. So this is the required answer for this question. All right. So next move to the next question is 1.1.3. All right. So x squared minus 2x minus 3, which is greater than 0. So this is a quadratic inequality. The first step is to find the critical values by solving the associated equality, which is we have x squared minus 2x minus 3 equals to 0. Okay, we have to factorize this equation. X squared minus 2x minus 3 equals to 0. And we have factor x squared minus 2x plus 3x minus 3 equals to 0. And we got x minus 2. Sorry, we have a number here. Factor out this x squared minus x plus 3, sorry, plus x, and right over there. We have x squared plus x minus 3x minus 3 equals to 0. And I'm taking x common. We got x plus 1 minus 3 common, x plus 1 equals to 0, right? So I'm just going to simplify x minus 3 and x plus 1 equals to 0. Now we have x plus 1 equals to 0 and we have x minus 3 equals to 0, x equals to minus 1 and x equals to positive 3. So what we say that about that? We say that x is less than minus 1 and x is greater than 3. All right? So this is we have a solution, and how we set the notation of this solution, we can write it be like that. X belongs to minus infinity minus 1, all right, union of 3 to infinity, all right. So the parabola y equals to x squared minus 2x minus 3 opens upward because we have a equals to 1 is greater than 0. We want the value of x for which the parabola is above the x-axis, okay? So move to the next question. The next question is about 1.1.4, okay? So we have 2 power of 2x minus 2 power of x plus 2 minus 32 equals to 0. So this is an exponential equation. We need to rewrite the terms so that we can substitute to form a quadratic equation. So use the exponent rule. Use this exponent rule when we have a power of m plus n, that is we have equals to am power m dot a power n. So, and recognize that we have a value, that is we have 2 power of 2x. So we can write it be like that, 2 power of 2, so power of x, and the whole power we can take 2, all right? We can write it be like that. So rewrite the equation firstly, and then we have to solve the question, all right? So we have 2x power square, right? And then we have minus 2 power of x dot 2 power of 2, okay? And this is equals to 32, minus 32 equals to 0, all right? So we have the equation be like that. We have 2 power of x taking square minus 4 into 2 power of x minus 32, that is equals to 0, all right? So let we have say that this 2x equals to k, all right? So we have k squared minus 4k minus 32. Now you can easily solve out this question. Like we have k squared minus, we have a plus 4k minus 8k minus 32, that's equals to 0. So I'm taking common and we have k plus 4 and we take minus 8 common from there. We have k plus 4 equals to 0. All right. So we just take the common is k plus 4 and k minus 8 that is equals to 0. All right. So we have the two values of k. All right. You have k equals to minus 4 and you have k equals to positive 8. Now it's time to substitute the value of k. As you know about that, we put the value of k is 2x that is equals to minus 4 and 2x that is equals to 8. So you can write the 8 and minus 4 also in the term of 2, power of 2. Like we have 2 power of x and I'm writing it like that. We have 2 power of 2, okay? And 2x equals to 2 power of 3. All right? So we take the positive value only and we cancel out this, we neglect the negative value and we just take the positive value. So we have the value of x is 3. Okay? So this is the required answer for this question. Now the second the last 1.1.5 is that we have minus 2x plus 4 minus x equals to 2. So this is the radical equation. The key is to isolate the square root on one side before squaring on both sides. So this will eliminate the radical, all right? So isolate the radical on one side. We have minus 2x plus 4 and we have 2 plus x. Now taking the square root on both sides, what we got? Minus 2x plus 4 equals to 2 plus x squared, right? So I'm just going to simplify the equation. 2x plus 4 equals to 4 plus x squared plus 4x, all right? So I'm just taking the all values on one side. We have an x squared plus 4x plus 4 plus 2x minus 4 that is equals to 0 and this is cancelled and we have the value of x squared plus 6x equals to 0. So I'm just gonna write over there the value of x that is x common and we have x plus 6 that is equals to 0 and now we got the value of x that is x equals to 0 and x equals to minus 6. All right. Now, scaling on both sides can introduce the extraneous solution. So you must check it out, both side solutions, that what is the which is the not solution, which is the solution of x. Okay. So now we have to put the solution in the equation to check that our which answer is correct. Okay. We have to checking this. So I'm just putting the value of x equals to 0. All right. Firstly, x equals to 0. So I'm just going to put 2 into 0 plus 4 minus 0. Okay. And what we got? We have square root of 2, square root of 4 minus 0 that is equals to 2. All right. So what is the square root of 4, which is 2 equals to 2. All right. So that means that the value of x equals to 0 is valid value. Okay. Now check when x equals to minus 6. Okay. We have 2 into minus 6 plus 4 minus into minus 6, okay? And that is equals to, we say, minus 6 plus 4 plus, sorry, minus 6 plus 2. All right? So 6, 12, and we have a minus, oh, sorry, we have equation. Okay, we have the 4 and we have plus 4. This is not nothing, okay? Plus 4 and plus 6, okay? That is equals to 6 um, plus 2. We have a minus 4 over there, and we have 12 plus 4 is 16 plus 6, that is equals to minus 4, and we have 4 plus 6, that is equals to, so 10 is not equals to minus 4. This means that the solution of this question is x equals to 0. This is the required answer for this question, okay? So moving toward the next question of question number 1. Now the second question is 1.2. So for x and y simultaneously, we have two equations, 2x plus y equals to 3 and y squared plus 2x, sorry, y squared plus xy equals to 2. All right, we have two equations and we have to find out the value of x and y. Okay, so I'm calling this is the equation 1 and this is the equation 2. Okay, so I'm just writing, take the value of y from equation 1 and then I put the value of y in equation 2. All right, so we have 3 minus 2x. Okay, so I'm just find out the value of y from equation 1 and I'm putting this value in equation 2. Okay, by putting equation 3 in equation 2. Okay, so we have 3 minus 2x squared 3 minus 2x equals to 2. Okay, so I'm just going to simplify this whole equation. Now we have a 9 plus 4x here, and we have a minus 3 to 6, 6 to 12x plus 3x minus 2x squared minus 2 equals to 0. I'm just taking 2 over there and I take the whole value equals to 0. Okay, whole terms equals to 0. Now I'm going to simplify the equation. We have a 2x squared and minus 12 and plus 3. We got over here minus 9x and we have a plus 9 minus 2. Here we have 7 equals to 0. All right, so this is the equation we have after simplification. So we have to solve this equation for quadratic, or you can solve it by quadratic, or you can solve with factorization. All right, so I'm going to solve this equation what we got. Okay, so we have a 2x squared we have 2x squared minus 2x minus 7x plus 7 equals to 0, right? So we just take 2x common, and we have an x minus 1. And in this, we have taken common minus 7, and we got x minus 1 equals to 0, all right? So we have a 2x minus 7, and we have x minus 1 equals to 0. So we have 2x minus 7 equals to 0, and we have x minus 1 equals to 0. Now, we're getting the value of x from there. We have a 7 by 2. Over here, we have an x equals to 1. So now we have the equation, the two values of x is a 7 by 2 and 1. So we have to find the value of y by using this, all right? So for y, what the value we have? So I'm just writing in case 1 when you have x equals to 1, okay? So we just put the value y equals to 3 into, sorry, we have 3 minus 2 into 1, that is equals to 3 minus 2, which is we have 1, okay? So case 2, we have x equals to 7 by 2, all right? Now we have y that is equals to 3 minus 2 into 7 by 2. Now we have 3 minus 7, and we got minus 4. So we have two values of y, which is 1 and minus 4. All right, so how we write? We have an x equals to 1, and we have y equals to 1. We have an x equals to 7 by 2, and we have y equals to minus 4. All right, this is the required solution for this question. The next question is 1.3. Consider the product of 1 plus 1 by 2, 1 plus 1 by 3, 1 plus 1 by 4, up to so on. Okay, so each factor in the product is of the form of 1 plus 1 by n, and for n greater or equals to 2. So determine all the values of n for which the product will be an integer value. Okay, so we are dealing with a product where each factor is of the form of 1 plus 1 by n, all right? So let's simplify the general form of the factor and look for a pattern by expanding the product, okay? So we have a solution. So we have a 1 plus 1 by n that is equals to n by n plus 1 by n. And I'm writing it like that. We have an n plus 1. So now let's write out the product of pk up to the factor when n equals to k, okay? When n equals to k, all right? So we have to write the product of k. I'm writing it to be pk, that is equals to 2 plus 1 divided by 2. We have 3 plus 1 divided by 3. We have 4 plus 1 divided by 4, up to so on. We have k plus 1 divided by k, okay? So I'm just going to simplify this pattern. We have 3 by 2, 4 by 3, 5 by 4, up to so on. We have k plus 1 by k, all right? So notice the telescoping nature of the product. The numerator of one term cancels with the denominator of the next term, okay? So when we do the cancellation, what we got? Pk. Pk equals to k plus 1 by 2. As you can see that, all right? This term is cancelled by this term cancelled by this, and this cancel out each term, and the left term is we have k plus 1. So the question asks for all values of n for which the product will be an integer value. So the least factor in the product is 1 plus 1 by n. So the product is the final value is n plus 1 by 2. Okay? We say that the condition for the integer value is that n plus 1 by 2 is the integer. All right? So for this fraction to be an integer, the numerator n plus 1 must be divisible by 2. So this means that n plus 1 must be an even number, and we have to determine n. So n plus 1 equals to 2m. For some integers, m greater or equals to 2, and we say that n equals to 2m minus 1. Okay, so if n plus 1 is even, then n must be odd. And since the product specifies that n greater or equal to 2, we are looking for all odd integers greater than or equals to 3. So the solution of the values of n is we have n belongs to 3, 5, 7, 9 up to so on, and n is the odd integer. We say n is odd integer. Okay, this is the required answer for this question. Now, the next question is question number 2.1. The first term of arithmetic series 7, the common difference of this series is 5 and the series contains 20 terms. So, the question number 2.1 having two parts, 2.11 and 2.12. So 2.1.1, calculate the sum of this series. All right, we have to calculate the sum of this. So for the sum of an arithmetic series, we use the formula which is Sn equals to n by 2, 2a plus n minus 1 into d. So we have n equals to 20 and we have a equals to 7 and d equals to 5. All right. So anyway, we just substitute the values in this formula and what we got. So S20 that is equals to 20 by 2, 2 into 7 plus we have 20 minus 1 d. Okay. So after doing simplification, we get 10, 14 plus 19 into 5 and 10 into 14 plus 95, and we got the value is 10 into 109, and after doing the simplification we got 1090. So S20 that is equals to 1090. This is the required answer for this question. All right, so the next question is that 2.1.2, the original arithmetic series is extended to 75 terms. All right, so the sum of these 75 terms is 14,400. Using sigma notation, write down the equation for the sum of the term added to the original series. All right. So the original series has 20 terms. It's extended to 75 terms. We have 2.1.2. Okay, so with total sum S75, we have S75 that is equals to 14,400. So the sum of the added terms we have is S75 minus S20. All right, so calculate the sum. All right, so when we calculating the sum, we have S75 is 14,400, and what is the S20? S20 is, we have calculated in previous. So we have sum equals to 13, 3, 10. So the term added are from T21 to T75. So we first need to the journal term Tn for the series using Tn equals to A plus into N minus 1 into D. So we have the journal term Tn. So let's put the values in this. We have 7 plus N minus 1 into 5. And we have 7 we have 7 plus N minus 1. We have a 5. We have to multiply 5 with it in the terms. So we have Tn and we have Tn equals to 5n plus 2. All right. So in sigma notation, the lower limit must be the term number of the first added term, which is n equals to 21. And the upper limit is the last term, that is n equals to 75. So expression in the journal form of t and in journal term Tn is, we can write it like that: summation n equals to 21 to 75 into 5n plus 2, that is equals to 13, 3, 10. All right, so this is the required answer for this question. The next question is 2.2. The sequence of the first difference of the quadratic pattern 1, 3, 5 up to so on. So the 2.2 having two subparts, 2.2.1. If T99 of this quadratic pattern is 9632, calculate the value of T98. Okay, and the second part is that we have if it is further given that the third term of the quadratic pattern is 32, determine the journal term Tn of the quadratic pattern. All right. So the given, so I'm solving the first is 2.2.1. The sequence of the first difference is 1, 3, 5 up to so on. All right. So we have T 99, that is equals to 9632, and we need to calculate T98. So the difference between T99 and T98 is the 98th term of the first difference sequence of D98. The general term of for the first difference sequence is Dn equals to 2n minus 1. And since A difference is equals to 1 and T difference that is equals to 2. So calculate D98, which is 2 into 98 minus 1. You multiply this number, 2 is 16 to 90. Okay, you just multiply this term. Minus 1. Okay, so we have a 195. So D98 is 195. Okay, so we know that T99 minus T98, that is equals to D98. So we say that T98 equals to D98 minus T99. We have a 9632 minus 195. So the value of T98 is equals to 9437. And this is the required answer for this question. Okay. So move toward the 2.2.2. Determine the journal term Tn for and given T3 is 32. So the journal term of the quadratic pattern is, we have Tn equals to an square plus bn plus c. we use the difference to find A and B first, then second difference is 2. Okay, so 2A, we can say that we have 2A equals to second difference, and second point is 3A plus B first difference. Okay, so let's find A and B first. So we have 2A equals to 2. So we have A equals to 1. And we have 3A plus B that is equals to 1. First difference D1 we have equals to 1. All right. So I'm just putting the value plus B equals to 1. Now we have B equals to minus 2 after solving this. Okay. So now use T3 equals to 32 to solve for C. Okay. So we have T 3 that is equals to 32. So we say T3 equals to A3 square plus B into 3 plus C that is equals to 32. I'm just putting the value of this. So we have 9 into 1 plus minus 2 into 3 plus C equals to 32, and 9 minus 6 plus C equals to 32, and we have the value of C equals to 32 minus 3, C equals to, we have 29. So we know about the value of A, B, C. So the journal term of Tn is journal term Tn. We have Tn equals to n squared minus 2n plus 29. And this is the required answer for this question. Okay? Now, the next question is question number 3. A circle with radius 6 centimeters is drawn. This is the one circle, okay? A second circle, smaller circle, is drawn to the center of the first circle and also touches the first circle internally, as shown in the diagram. A third, smaller circle is drawn through the center of the second circle and touches the second circle internally. The process of the drawing circles continues and forms a geometric pattern. All right, we have 3 questions about question number 3. The first is 3.1. Write down the radius of the third circle. This is 1, this is 2, and this is third. We have to calculate the radius of this third. Calculate the sum of the areas of first 10 circles. And 3.3 is which circle has a diameter of 3 by 120. So let's solve the questions. Okay, before solving the 3.1, we have a radius R1 of the circle 1. Okay, circle 1, larger circles. The radius R1 is 6 centimeter. And for circle 2, we have R1 is the diameter is R1, which is 6 centimeters. So R2, we have 6 centimeter divided by 2. We have a 3 centimeter. Okay, so circle 2, the radius of circle 2 is 3 centimeter. And the radius of, the radius of circle 3 is we have R3. Circle 3. R3 is we have 3 by 2, all right? So it is 1.5 centimeter, okay? So these are the circles, and if we say the radius of the circles, the sequence, radii sequence Rn, that is we have 6, 3, 1.5 up to so on. Okay, and the common ratio K for this, we have K equals to R2 by R1, and which is 3 by 6, that is equals to 1 by 2. Now, let's solve the question number 3.1. Okay, in 3.1, write down the radius of the third circle. Okay, we have to calculate radius of third circle. Okay, so the radius of the nth circle Rn is half of the radius of the n minus 1th circle. We found the first radius R1 equals to 6 and R2 is equals to 3. Okay, we have R1 that is 6 and we have R2 that is 3. So we have R3 equals to 1 by 2 R2, and I'm just putting the values in this, and we have 3 and we got 3 by 2. So we say that the radius of the third circle is 3 by 2 centimeter. Okay, I'm writing over there. This is the required answer for this question. So let's move to the 3.2. Okay, for the 3.2, we have to calculate the sum of the areas of the first 10 circles. This is we have to calculate, okay? So the area of the circle, as you know about that, is area of the circle is equals to pi r square. So I'm writing in the sense of n, we have writing rn square, all right? So if we create the sequence, sequence of areas, we have an, we have a1 that is equals to pi into 6 square, which is equals to 36 pi. We have a2 pi into 3 square, that is equals to 9 pi. We have a3 that is equals to pi into 3 by 2 whole square, that is equals to 9 by 4 pi. So this is a new geometric series. We need its first term a and common ratio r. Okay, so the first term a equals to a1, that is we have 36 pi. Okay, and r, how we calculate r? R equals to, we have a2 by a1, and that is we have right 9 pi by 36 pi, that is equals to 1 by 4. So since mode of r is less than 1, the series of converges but only need the sum of the first 10 terms. We use the formula Sn equals to a into 1 minus Rn divided by 1 minus r. Okay, so we have to calculate Sn, which is equals to 36 pi, which is equals to 36 pi into 1 minus 1 by 4, 10, and divided by 1 minus 1 by 4. All right, so I'm just going to simplify this equation. We got 36 pi into 1 minus 1 by 4 whole power 10. And after solving 1 minus 1 by 4, we got 3 by 4, okay? So do the more simplification in this question, and we got a 36 pi dot 4 by 3 into 1 minus 1 by 4 power of 10. And then so far further, we got the value is approximately 150.80 centimeters square. Okay, I'm adjusting the two decimal places. So S10 is equals to this value. This is the required answer for this question. All right. So let's move to question number 3.3. In 3.3, which circle has the diameter equals to 3 by 128? Okay. So first convert the given diameter to a radius. All right. We have a dn that is equals to 3 by 128 centimeters. So Rn equals to 1 by 2 dn. And I'm converting my diameter into radius. We have a Rn equals to 1 by 2, 3 by 128. And this is equals to 3 by 256 centimeter. Okay. So the journal term for the radius sequence is Rn equals to r power of n minus 1, where a equals to r1 and this is equals to 6 and r equals to 1 by 2. And we have just set up the equation and putting the values Rn equals to 6 into 1 by 2 n minus 1. And what is the value of R1? We have is 3 to 56 equals to 6 into 1 by 2 power of n minus 1. I'm just going to simplify the equation. We got 3 by 256 multiplied with 6, that is equals to 1 by 2 power n minus 1. All right. So since 512 is equals to 2 power of 9. Okay. If you multiply this, we have got 512 that is equals to 1 by 2 power n minus 1. So I'm just going to convert a 1 by 2. Okay. Sorry, we have a 1 over here. When we cancel out the terms, we have a 1 power of 9 equals 1 by 2 power of n minus 1. So when the bases are same, we have 9 equals to n minus 1. And we have the value n is equals to 10. All right. So this is the required answer for these questions, that the diameter belongs to 10th circle, means that 10th circle diameter is 3 by what? Is 3 by 128 centimeters. So this is the required answer for this question, okay? Now the next question is question number 4. Given f of x equals to a power of x minus 1 for a greater than 0, b into 2 minus 5 by 9 is a point on f. Calculate the value of a. Okay, we have the given function f of x. All right, we have to calculate to find the unknown base a. We substitute the coordinates of the given points b, which is x or f of x, into the function's equation. Okay, so we have a function equation f of x that is equals to a power of x minus 1. All right, so I'm just substituting the value of these values in this function value. So we have a 2a power of 2 minus 1, and we got 5 minus 5 by 9. Okay, now solve for a square. So when we're solving for a square, what we got? We have a square equals to 1 minus 5 by 9. So a square equals to 9 by 9 minus 5 by 9, that is equals to 4 by 9. Now you can solve for a. Now solve for a. Okay, we have a equals to 4 by 9, that is equals or you can say that A equals to minus 4 by 9, right? So we have A equals to 2 by 3 and A equals to minus 2 by 3. So since the problem states that A is greater than 0, so we choose this positive value. Okay, so the solution of the required solution is A equals to 2 by 3. Okay. Now taking question is 4.2, write down the range of f. Okay, so the function f of x we have equals to, this is we have an equals to 2 by 3 power of x minus 1. So the horizontal asymptote for an exponential function y equals to b power of x plus q, and y equals to, we say that is equals to q, because q over here is equals to minus 1. All right, so the asymptote, the horizontal asymptote is y equals to, we say that this is y equals to minus 1. Okay, so for an exponential function, b power of x is greater than 0. So therefore, we say that if we say that b power of x is greater than 0, then we can say that b power of x minus 1 greater than minus 1. All right. So the answer of the range is we have y greater than minus 1, or we can say that y belongs to minus 1 infinity. Okay, this is the required answer for this question. The next question is 4.3. Sketch the graph of f clearly. Show the intercepts with the axis and asymptote, if any. Okay, so we need to equation of the asymptote, the y-intercept and the x-intercept to sketch the graph. So asymptote is we have, that is y equals to minus 1. Okay, and the y-intercept, for y-intercept we consider x equals to 0. Okay, so we put the in function f of 0, that is equals to 2 by 3 power of 0 minus 1, 1 minus 1 equals to 0. Okay, and the intercept we have 0 and 0. All right, so for x-intercept we consider, for x-intercept, consider y equals to 0, and you put the y function that is equals to 0. Sorry, we have to put for x-intercept, we have to put, we have to put f of x equals to 0 instead of y. Okay, just going to over there, I'm just going to put f of x equals to 0. So I put over there, we have 2 by 3 power of 0, 1, sorry, power of x. So we have an a 1 equals to 2 by 3 power of x, and that is equals to, we say that is equals to x equals to 0. Okay, so the intercepts are 0 and 0 in this. Intercepts we have 0 and 0. So since how shape the graph? So since we have an a equals to 2 by 3 and 0 less r equals to a equals to 2 by 3 and 0 less than a less than 1. Okay, so the function is decreasing. So how we write the graph? The graph shown be like that. Okay, the graph is looks like that. We have these two O point and B point, and this is the y value, which is -1. All right. Now, the next question is 4.4. It is further given that C is a point of on F at y equals to 19 by 8. Determine the coordinate of C power F, the image of C when C is reflected about the line y equals to x. All right. So we have an first we need to coordinate the of point C, and we are given that C is on F at y equals to 19 by 8. So we have to find the x coordinate of C, okay? We have to find the x coordinate of C. So if f of x equals to 19 by 8, and 19 by 8 equals to 2 by 3 power of x minus 1, okay? So we just have simplify the equation, which is 2 by 3 power of x, and we got 19 by 8 plus 8 by 8 equals to, we have 2 by 3 power of x, and we got 19 plus 8 by 8 equals to 2 by 3 power of x. Okay, and then we have over here 27 by 8 equals to 2 by 3 power of x. Now rewrite both sides with a common base, since 27 is equals to 3 cube and 8 is 2 cube. So we just have to write in the base of 3 by 2. Okay. 3 by 2 power of cube equals to 2 by 3 power of x. All right. So I just flipped this term. We have 2 by 3 power is minus 3 and 2 by 3 power is x. Since the bases are the same, so we have the value of x that is equals to minus 3. So the coordinates of C is we have minus 3 and 19 by 8. All right. So a reflection about a line y equals to x is the transformation that produces the inverse function. So this transformation swaps the x and y coordinates. Okay. So we say that the c, x, and y, it swaps, like we have y and x. So the coordinates of C prime is we have is 19 by 8 and minus 3. Okay? This is the required answer for this question. Next question is question number 5. Sketched below is the graph f of x equals to a by x plus p plus q, having the domain is minus infinity 1 union to 1 infinity. So the graph of x f cuts the y-axis, as you can see over there, at 0 and 1. A line of symmetry of f is given by g of x. This is the g of x. This is equals to x minus 3. So the first question of question number 5 is 5.1. Write down the value of p. So the domain is determined by the vertical asymptote, that is x equals to about vertical dot, we have an x equals to minus p. Since the domain excludes x equals to 1, the vertical asymptote must be x equals to 1. So solve for p equals to 1. So for p, we have p minus p equals to 1, and we get p equals to minus 1. So the function is right now, we have f of x equals to a by x minus 1 plus q. All right, this is the required answer for this question. So the next question is about 5.2. So determine the equation of the horizontal asymptote of f. So the lines of symmetry for a hyperbola are y equals to x plus c and y equals to minus x plus c prime. So where c and c prime are the constants and these lines intersect at the point of intersection of the asymptote, like x and y. All right, so the asymptote intersection, the point is 1 and y asymptote. So we have to substitute the x coordinate of the intersection point x equals to 1 into the given line of symmetry, that is g of x equals to x minus 3. Find the coordinate y coordinate, which is the horizontal asymptote, y equals to q. So calculate the q. Q equals to g of 1. This is 1 minus 3, and we say that the q equals to minus 2. So the equation of horizontal asymptote is y equals to equation of horizontal asymptote y equals to minus 2. All right. So this is the answer of this question, required answer. Okay. So the next question is about 5.3. We calculate the value of a. So we know have f of x equals to f of x equals to a by x minus 1 minus 2. All right. So we use the given y-intercept. This is 0 and 1 by substituting x equals to 0 and f of x equals to 1. Solve for a. Okay. So I'm just going to put over there, we have f of x equals to 1 and a by 0 minus 1 minus 2. Okay. So we just have the value I'm putting over there, 1 equals to a by minus 1 minus 2, that is equals to 1 equals to minus a minus 2. And so for a, we have a equals to minus 2 minus 1. This is equals to minus 3. So the final function we have is f of x equals to minus 3 by x minus 1 minus 2. This is the required answer for this question. Okay. Next question is 5.4. For which values of x is f of x greater than 0? So we are looking for where the graph is on or above the x-axis, okay? So we first find the x-intercept by setting f of x equals to 0, all right? So let's start. We said find x-intercept, okay? And for x-intercept, I'm setting the f of x equals to 0, all right? So just put in the equation 0 equals to minus 3, x minus 1 minus 2. So I'm just going to simplify the equation. We have a minus 3 by x minus 1 equals to 2. And we have minus 3 equals to 2x minus 2, and we have a 2x minus 2 plus 3 equals to 0, and do further simplification. We have over here 2x plus 1 equals to 0, and we have 2x equals to minus 1, and we have x equals to minus 1 by 2. All right. So from the graph of f of x is above the x-axis between the x-intercept and the vertical asymptote. Okay. So we have to determine the inequality range. Okay. So the function is greater than 0 when x is the greater than or equals to x-intercept. So we can write it like that. The range is minus 1 by 2 less or equals to x and x less than 1. All right. Or you can write this thing be like that. X belongs to, you can write it be like minus 1 by 2 and 1. Okay. And this is the required answer for this question. Okay. Now the next question is 5.5. Graph f undergoes a transformation to h where the domain and range of h are the same as that of f, and h prime of x, the derivative of h, is negative on its domain. Okay, so describe a possible transformation that f could have undergone to result in h. Okay, so let's solve. So the transformation f, okay, the transformation f to h must satisfy three conditions. All right. So the first condition is its domain. Okay. The first condition is domain. So this means that the asymptote must remains at x equals to 1 and y equals to minus 2, which is center of the hyperbola, and transformation must map like we have 1 and minus 2 onto itself. And the second thing is derivative of h prime of x is negative. Derivative of h prime of x is negative. Okay. So the derivative of f prime of x is 3 by x minus 1 is positive on its domain a equals to minus 3. For the derivative to be negative, the new function h of x must be decreasing. We have an f prime of x equals to 3 by x minus 1 here. This is the positive, and for a is equals to minus 3. Okay, so we have a function h of x must be decreasing on its two branches, meaning the constant a in the transformed function must be positive. So a new is greater than a new is greater than 0. Okay. The third condition is transformation must keep. Third condition is that we have the transformation must keep at 1 and minus 2. Okay. So possible, this is the first question, and the second question of 5.5 is 2. So the possible transformation satisfying the condition reflection about the line y equals to minus 2, and this flips the branches while keeping the asymptote same. Like we have h of x h of x equals to minus f of x plus 2q. So we say that h of x equals to minus into minus 3x minus 1 minus 2 plus 2 into minus 2, and this is equals to 3 by x minus 1 plus 2 minus 4, and this is equals to 3 by x minus 1 minus 2. Okay. So the new value is a is greater than a equals to 3 is greater than 0. Okay. So the reflection about x, this is the reflection, the above reflection is about y equals to minus 2. And now the reflection is about, I'm writing over here, the reflection about x equals to 1. The vertical asymptote. This flip the branches across the vertical axis while keeping the center and a value the same. So since a is preserved, h remains increasing. A is preserved and h remains increasing. Okay. So which contradicts the condition h prime of x is less than 0. So this transformation is not valid. Okay. So the third is reflection about the line. We have y equals to minus x about y equals to minus x plus c. So this keeps the substrate but changes a. Okay. So the conclusion is that we say that f is reflected about the line y equals to minus 2, right? So the simplest transformation that swaps the sign of a while maintaining the asymptote is a reflection about the horizontal asymptote, okay? So this is the required answer for this question. Now we have the question number 6. In the diagram below, the graph of f of x is equals to minus x squared plus 4x plus 5 and g, a straight line are drawn. C is the point, coordinates are 3 and 8, is a point of intersection of F and G, okay? EH is drawn parallel to the y-axis. Okay, this is the EH. This is the point E. Okay, this is the point E and this is the point H. Like with E a point on F, E is the point on F, and H is the point on G. All right. So we have the question number 6 has the subparts. The first question of question number, the first part of question number 6 is 6.1. Calculate the coordinate of B, the turning point of F. Okay. So to find the turning point, we have, okay, to find the turning point and B, we have the B. So let's suppose we say that the coordinates of B, we say that X, B, and Y, B. Okay. So we use the formula for the X, for the axis of symmetry. So XB, which is equals to, we take minus B by 2A, and the values of AB. And what we have to find out the values of the functions AB, and we have the function f of x that is equals to minus x squared plus 4x plus 5. All right. So I'm just going to put the values. All right. So we have the value of A is minus 1, the value of B is 4, and the value of C is 5. So I'm just putting the value in this equation. We have an xb that is equals to minus 4 by 2 into minus 1, that is equals to positive 2, because we have the minus 1 and minus 2, and the answer is positive 2. All right. So this is the value of xb, all right, the x coordinate. And now we have to calculate we have to substitute the value of xb into the function to find the coordinate of phi b. All right. So we have a yb, that is, we say that equals to f of 2 is equals to minus 2 into square plus 4 into 2 plus 5. All right. So we have a 4 plus 8 plus 5. All right. So 8 minus 4, we have the value is yb equals to 9. So the coordinates of b is, hence, coordinate of b, which is, we have what? 2 and 9. Okay, this is the required answer for this question. The next question The next question is 6.2. Show that the equation of the line through A and C is given by g of x, that is equals to 2x plus 2. All right. So the points A and C are the intersection points of f of x and g of x. Okay. A and C are the intersection points on function f of x and g of x. Okay. So we already know the coordinate C, that is, we have 3 and 8. And first, let's find the x coordinate of the intersection by setting f of x equals to g of x. Okay, using the given equation of g of x. So let's do how we solve it. So we set the equations of, we have to write f of x equals to g of x. So what is the equation of f of x? We have minus, that this is the given, minus x squared plus 4x plus 5, that is equals to 2x plus 2. Okay? Now we have to take all the values on one side. All right, we have an x squared plus 2x plus 2 minus 4x minus 5, that is equals to 0. So we have x squared minus 2x minus 3. All right, that is equals to 0. Now we have to factor out these values. We have an x squared plus x, all right, minus 3x minus 3, that is equals to 0. So we take x common, x plus 1. Here we take minus 3 common, x plus 1 equals to 0. So we have x plus 1 and x minus 3. So the values of x are, we have x equals to minus 1 and x equals to 3. All right. So the x coordinates, we have this. So the y coordinate, um, we have the x. This is for point C, and this is for point A. Okay. Now to confirm g of x, okay. So the y coordinate of A is g of into minus 1, that is equals to 0. Okay. So we say that A is minus 1 and 0, because when you write g into minus 1, that is equals to 2 into minus 1 plus 2, that is equals to 0, right? So then to confirm g of x equals 2x plus 2, okay, first we have to calculate the gradient m using a and c to find gradient m by using a, that is 0, and c, that is 3 and 8. Okay. So we have m, that is equals to yc minus ya divided by xc minus xa. Okay. So we have 8 minus 0 divided by 3 minus into minus 1. Okay. And then we have the value is 8 by 3. 3 plus 1, this is 8 by 4, and we have the value is 2. All right. So using the point slope from with A, okay, using point slope form with A, that is minus 1 and 0, what we get? Let's see. So we have equation y minus ya equals to m into x minus xa. And we have right y minus 0 equals to 2 into x minus. Okay, so y equals to 2x plus 2. And the equation we have, as you can see that this shows the equation of the line is indeed g of x equals to 2x plus 2. And this is a required thing that we need to write over here, okay? Now, the next question is 6.3. Calculate the maximum length of EH for F greater than G, okay? So we have to solve the length of EH since it's parallel to the y-axis. So is the vertical distance between the two functions. Since E is on F, as you know that E is on F, okay? And and the H is on G. So the length of f of x is length of L of x is we have f of x minus g of x. So we must find the maximum value of this function L of x between the intersection point x equals to minus 1 between the points x equals to minus 1 and x equals to 3. Okay. So first we will set up the length of the function, which is we say that L of x equals to the value. We have tried the value of f of x, which is minus x squared plus 4x plus 5 minus into 2x plus 2. This is the value of g of x, okay? So let's solve this equation. We got minus x squared plus 4x plus 5 minus 2x minus 2. So we have minus x squared plus 2x plus 3. So this is the equation of L of x, and this is the downward opening parabola. So its maximum will occur at its vertex. All right. So we have to find the x value of the maximum either by using x equals to minus b by 2a, or you can by using differentiate where L prime of x equals to 0. All right, so we have to differentiate this method. It's easiest method. Okay, so f of x equals to what is the derivative of minus x squared? We use the power rule. All right, so minus 2x, 2 minus 1 and 1, and this is 2, this is 0. All right, so we have minus 2x plus 2. All right. And what did we have? We have for the maximum value. So for the maximum value, we put L of x equals to 0 for maximum. Okay. So we put 0, which is equals to minus 2x plus 2. And we have minus 2x plus 1 equals to 0. And we have x plus 1 equals to 0. X equals to minus 1. We have when we take the minus common, we have over here minus, all right? So we have the positive 1 over there, all right? So the maximum length occurs at x equals to 1, which is between the x-intercept of L of x at x equals to minus 1 and x equals to 3. Now we have to find the maximum length, L maximum, okay? For L maximum, we have to substitute x is equals to 1 into the L of x, okay? So L of, this is L of 1, and we have to substitute this equation. This is, we have minus into 1 square plus 2 into 1 plus 3, and we have a minus 1 plus 2 plus 3, and what we got? What we have a 4. So L maximum is equals to 4. So the maximum length the maximum length of EH is 4 unit. All right. This is the required answer for this question. Now, the next question of six question is 6.4. Given k of x that is equals to f into x plus m, this is equals to minus x square minus 2mx minus m square plus 4x plus 4m plus 5. We have to determine the value of m such that g is tangent to k, okay? So we have the k of x is the function f of x shifted horizontally by minus m units. So if g of x is the tangent to k of x, they must intersect at exactly one point. So this means that when we set k of x equals to g of x, the resulting quadratic equation have a discriminant that is del equals to 0. So firstly, we substitute f of x plus m into the equation of k of x, okay? So let's start it. Okay, we have the k of x that is equal to, they already give the expanded form. So like they already given us the expanded form of that k of x equals to g of x, okay? Right? So we have minus x square minus 2mx minus m square plus 4x plus 4m plus 5, okay? And we have over here minus x square minus 2mx minus m square plus 4x plus 4m plus 5, that is equals to 2x plus 2. We have set f of x equals to g of x, and this function we say that equals to f of x plus m. All right? So I'm just writing over there, and you have to substitute the values. We have minus x squared plus minus 2m plus 4 plus, sorry, minus 2 into x plus into minus m squared plus 4m plus 5 minus 2 equals to 0. So I will rearrange the equation into the quadratic or standard form, you can say, right? Like ax squared plus bx plus c, all right? In this form. So we have to take multiply with this whole equation with minus 1. So we got x squared plus 2 minus 2m into x plus m squared minus 4m minus 3. Okay? I just multiply this whole equation with you can write me like that, minus x squared plus into minus 2m plus 2 into x plus minus m squared plus 4m plus 3, that is equals to 0. And now when I multiply with minus 1, the equation becomes like that, all right? So we have this the equation, the standard form. Now, from the equation, you can find A is 1, This is A, that is equals to 1, B equals to 2 minus 2m, and the C that is equals to m square minus 4m minus 3. Okay, so we have discrimination into the 0. The discriminant we have that is equals to 0. If I put the equation like we have 2m minus 2 taking whole square minus 4 into 1 into m square minus 4m minus 3 equals to 0. Okay, so we have to expand and simplify the equation to solve for m. Okay, now we have to solve this equation for m. So you just have to open this equation. We have using over here the formula a minus b whole square, that is equals to a square plus b square minus 2ab. Okay, so we have 4m square plus 4, and we have a minus 2 to 4, 4 to 8m into minus 4m square plus 4, 16m plus 12, that is equals to 0. All right, so we have over here, as you can see, that minus 4 and plus 4m square is cancelled, and we have 16m minus, so we have an 8m and plus 12 plus 4. All right, is 16, that is equals to 0. So we have a value of m. This is equals to minus 16 by 8. Okay, you can see that 8m equals to minus 16 because over here the positive value. And now we have m equals to minus 2. All right, this is the value of m, such that we have g is the tangent to k. So this is the required answer that we need to find out in this equation. Okay? Question number 7. 7.1. We have Maria's grandparents deposited our 5,000 into the saving account on the day that she was born. The account pays interest at the rate of 6.8% P.A compounding quarterly. Calculate the accumulated amount in this account on Maria's 16th birthday. Okay, so we have to solve this. This is a standard compound interest problem. So we use the formula, that is, we have a equals to P into 1 plus I by M, T, power of MT. Okay, now from the, let's see what are the given data over here. We have the P, this is equals to R 5,000. And the I is, we have is 6.8% P dot A. And what is the next we have? We have the compounded quarterly is compounded quarterly, which is m equals to 4, and the time, which is t, that is equals to 16 years. Okay, so now we have to substitute all the values in the equation. Right above we have an a, p is 5,000, 1 plus 0.068 divided by 4 and we have 4 multiplied by with, sorry, 16. All right, so we have to calculate the effective rate per period and the total number of compounded periods, and then we have to find the final accumulated account. Okay, so let's solve the equation. We have A equals to 5,000. So the rate of effective rate is, sorry, I'm writing over here 5,000, and after solving this, we are fine. When we're solving this, we get the answer is 1 plus 0.017, okay? Multiply by 16. 5,000 on our side. So after solving this, we get 1.017 power of 64. And after solving this, we get the value is R 14,788. R 788.45. Okay, so the accumulated account is we have accumulated account is we have R14788.45. Okay, so this is the required answer for this question number 7.1. So the next question is 7.2. After 4 years, the value of a printer was half of its original value. Determine the rate at which the value of the printer depreciated over this period. If the depreciation was calculated according to the straight line method. Okay, so we have the straight line depreciation formula, that is we have A equals to P into 1 minus iota dot T. All right, so we have we having the given values that A is the half of the original value P, and the time T is 4. What is the A we have? Half of P, and the time we has is 4 years. Okay, so we have the set of the equation. This is we have 1 by 2p. I'm putting the values in this equation, which you can call this equation 1. And we have p into 1 minus iota dot 4. All right. So we can divide both sides by p, assuming that p is not equals to 0. Okay. So I'm dividing both sides with p. What we got? We have 1 by 2 equals to 1 minus iota dot 4, and I can write this 0.5 equals to 1 minus 4 iota. Okay, so I'm just taking all the value on one side. 4 iota minus 1 minus 1 plus 0.5, that is equals to 0, all right? So just write over there. We have a 4 iota, and it is equals to minus 0.5 equals to 0. And we have iota equals to 0.5 divided by 4, and you get 0.125, all right? So we have express that this depreciation rate iota as a percentage, so we can write it iota equals to 0.125 multiply with 100%, and we got iota equals to 12.5% P dot A. So the annual depreciation rate is 12.5%. Okay, this is the required answer for this question. Okay, so let's move to the next question, which is 7.3. So in 7.3, the tea shop was granted a loan of 10,000 on 1 March 2022 at the interest rate of 13.5% P dot A compounded monthly. The Tishupu, Tishupu agreed to repay the loan over 5 years in monthly installments of R 2398 starting on 1 April 2022. So we have the two subparts of 7.3. The first is 7.3.1. Calculate the total interest that he will pay over the 5 years. And the 7.3.2 that Tishipu paid are 22,398 his monthly installment, and the additional are 20,000 on 1st March 2024 into the loan account. He continues to pay the original monthly installment. Thereafter, how many months earlier will Tishipu repay the loan? Okay, so let's solve the first question. This is, we have 7.3.1. Okay, so Tishipu loan is our 100,000, and he repaid it over 5 years in a monthly installment of our 2300.98. The total interest paid is simply the total amount he pays back minus the initial loan amount. We can calculate the total number of payments and the total amount repaid. Okay, so let's have a write the numbers over here. All right, so the total time, which is 5 years. Okay, and the payment per year is 12 monthly. Okay, and the total payments, that is, we have n, which is equals to 5 multiplied 12 equals to 60. Okay, so monthly installment, we have monthly in that is x. We have, this is r to 300.98. Okay, so the total amount repaid, total amount paid is 60 multiplied R 2300, and we have over here answer is R 138,058.80. Okay, so this is the total repayment. Now, what we have? What is the total interest? We have to find out the total interest. So, total interest is equals to total repaid is minus loan amount. Okay, so we have total interest is R38,058.50 minus R. Okay, so we have the total interest is R38,058.80. Okay, this is the total interest. Okay, so this is the required answer for this question. So let's solve 7.3.2. Okay, Tishipu paid R 22,300.8. Okay, on 1st March. So this is the challenging part. All right. A lump sum payment changes to outstanding balance. Okay, so calculate the outstanding balance after 24 payments. So the loan started from 1st March to 2022. The payment is made 1 March 2024, which is exactly 2 years, or you can say that 24 months later. So we must find the OB. This is outstanding balance, okay? Using the present value infinity formula solved by for n remaining is equals to 36 months, all right? So, or by using the future value approach. So let's use later the accuracy. So determine the OB value. This is, we have after the extra payment, that is R 20,000. Okay, so the payment on this date is this. So we have, this is, we have like R 300.98. This is the installment. Okay, plus R 20,000. This is the lump sum. Okay, so we have to calculate the monthly interest rate. All right. So which is, we have iota that is equals to 0.135 divided by 12, that is equals to 0.01125. Okay. So how you calculate the OB, outstanding balance? Okay. How we can write outstanding balance. You can write OB 24. Okay. So the formula is, we have OB equals to A loan minus F installments. Okay, so we have, right, A loan equals to P into 1 plus iota power of n, that is equals to 10 100 1 plus 0.135 divided by 12 power of 24, and this is equals to, we have 130,836.70. and the F installments, that is equals to X. Be careful about the calculations, okay? We have iota power of n minus 1 and divided by iota. Okay, I'm just putting all the values in this. 2300.98 1 plus 0.135 divided by 12. Okay, this is the iota. Okay, and power of 24 minus 1, and the whole thing is divided by 0.135 divided by 12. Okay, so do the simplification over here. After simplification, we have the answer is 62512. Sorry, 14.93. Okay, now you just put OB before lump sum. Okay, this is equals to 130 point sorry 836.70 minus 6251493. So the answer is we have R 68,32177. Okay, so this is the balance. The full payment on 1st March 2024 is R 22,300.98. Okay, so but since the R 2300.98 installment was already accounted for in the reaching in the balance of R 68,321.77, so the additional reduction in the principal is the lump sum of R 20,000, what is the new balance OB new. Okay, so we call it OB new. How you can write the OB new is, which is equals to OB before lump sum minus additional payment. Okay, so we can write it R 68,321.77 minus R2. The answer is we have R 48,321.77. This is equals to OB new. Okay, so now we have to find out the final, the new payments. Okay, what is the N? By using the formula of PV equals to X into 1 minus 1 plus iota whole right. Okay, to find the new number of the payment N required to pay of R 48,3 to 1.77 using the original installment of R 23. Okay, so we have the formula is PV equals to X 1 minus 1 plus iota power minus N divided by iota. So I'm just putting the values in this. Okay, so we have 48,321.77 to 300.98 into 1 minus 1 plus 0.135 by 12 power of minus n divided by 0.13512. Okay, so I'm just solving this and multiply with this value over here. 4232177 multiply with 0.011 0.01125 equals to 2300.98 into 1 minus 1.01125 power of minus n. Okay, and when you're solving this, we get 543.62 equals to, we have 2300.98, and this is equals to, we have into 1 minus into 1.01125 power of minus n and whole power. Okay, so be careful about the calculations. We have now we have 0.23625 equals to 1 minus power of 1.01125. This is the power, okay, minus n. Okay, so I'm just taking this value on this side, and we have minus from the, okay, I'm resisting. This value goes to over there and this value goes over there. We have a 1.01125 power is minus n and 1 minus 0.23625. Okay, so what we got? We have the value is 0.76375. Okay, this is 1.01125. So taking log on both sides, so we have when you take log on both sides, okay? I'm writing it. So we have over here minus n natural log, okay? Into 1.01125 equals to natural log of 0.7676375, right? So we can easily find out the value minus n, that is equals to 0.01118, and this is the value we have is minus 0.2693. Okay, and we have an n equals to this minus, these two minus going to cancel each other, and we have 0.2693 divided by 0.0118, and the answer is 24.08. Okay, so the n we have is 24.08 months. All right, so the original remaining payments were 60 minus 24 equals to 36 months. The new required payment are 25 months. Okay, so the month saved, that is equals to 36 minus 25 equals to 11 months. Okay, so Tishupu will repay the loan 11 months earlier. Okay, So this is the required answer for this question. Question is we have question number 8 in which we have to determine the derivatives of the functions. Okay, so the first question is 8.1. We have in 8.1 we have two parts of the question, 8.11 and 8.12. Okay, so firstly we have to solve this question 8.1.1. Okay, so derivative of dx into 3x minus 5x squared. Okay, so we have to find out the derivative of these terms. You can write it separately. Okay, so as you know about that, the derivatives we take the constant outside like this, and the derivative of x is 1, now 5, and the derivative of x squared we use over here power rule. Okay, the power rule, when you take the derivative of this, we have n x power n minus 1 and then derivative without power. So we have 2x into 1. Now we have 3 minus 10x. And this is the required answer for this question. Okay, so next is 8.1.2. All right, we have the function g of x, that is 2 by x squared minus square root of cube root of x power 7. Okay, so we have to find out this question, the derivative of this question. Okay, so let's solve it. Okay, so I'm writing the question over here and then we have to solve. We have the question is g of x, that is equals to this we have 2 by x squared, 2 by x squared minus cube root of x 7. Okay, so I'm just converting the equation x squared minus x 7 by 1 by 3, and this is equals to, we have 2 x minus 2 minus x 7 by 3. Okay, this is g of x. So let's find the derivative of this function. We have 2 into minus 2x minus 2 minus 1 into 1. Okay, minus 7 by 3 into x 7 by 3 minus 1 into 1. Okay, so you just go and simplify the equation, and we have 2 into minus 2x power of 3 minus 7 by 3 x power is 4 by 3. Okay, so this is 4x minus 3 minus 7 by 3 x power of 4 by 3. So this is the required answer of this question. Okay, minus, sorry, over here we also have a minus 4x cubed. Okay, so let's move to the next question. The next question is 8.2. Determine the equation of the tangent to function f of x equals to x cubed for x squared plus 2x plus 3 at x equals to 2. Okay, as you know about that, the equation of the line that is equals to y equals to mx plus c, and we need two things, the gradient m and the coordinate and the points. Okay, so we have the gradient m is the value of the derivative of x, f of x at x equals to 2 is the value of m. Okay, this is the gradient. All right, and the points we can find out by putting the points find out by f of 2. Okay, now let's start. First of all, we take the derivative of this function. We have now f prime of x equals to, I'm just taking the direct derivative, like we are using over here the power rule, like 3x3 minus 1 power 1, okay, minus 4 into 2x 2 minus 1 into 1, okay, plus 2 into 1 and 3 is equals to, the derivative of constant is 0. So we have 3x squared minus 8x plus 2, okay? So this is the derivative of function f of x. Now, substitute the value of f of x, okay? F prime of x equals to, when we put x equals to 2 in a function f of x, we got the value of m, okay? So m equals to f prime of 2, 3 square minus 8 plus 2. So we have 3 multiplied by 4 minus 16 plus 2. 12 minus 16 plus 2. And we have the gradient value is m equals to minus 4 plus 2, that is equals to minus 2. So m equals to minus 2, all right? So the gradient of the tangent is minus 2, okay? So now we find out the point of tangency by calculating f of 2. This gives the us the y coordinate, okay? Now I'm just putting f of 2 equals to 2 cube minus 4 2 square plus 2 into 2 plus 3. So this is 8. This is, we have 4 and 4, 16 plus 4 plus 3. And we have 4 plus 3 is 7. 7 plus 8 is 15. And we got over here minus 1. So we say that this is equals to y 1. Okay? So the point of tangency is 2 and minus 1. Okay? So we have the gradient m, we have the point. Now use the point slope form of the equation and put the values, because we have to find out the equation of tangency, okay? So we have the value is y1 m into x minus x1. So y minus into minus 1 and m equals to minus 2 and x equals to 2. So we have y plus 1 equals to minus 2x plus 4. Now, we can write it like that. Y equals to minus 2x plus 4 minus 1. So y equals to minus 2x plus 3. So this is the required equation that we need to find out in this question. All right? So let's move to the next question, which is sorry, which is we have 8.3, okay? In 8.3, we have the three subparts, 8.3.1, 3.2, 3.3. So we have the function f of x equals to minus gx squared. So firstly, we have 8.3.1. Determine f prime of x from first principle, okay? So from the first principle, this is the core calculus concept. So we use the definition 8.3.1, okay? So we use the definition which is f prime of x equals to limit h approaches to 0, f of x plus h minus f of x divided by h, okay? So I'm just putting the values and we have to find out f x plus h, that is equals to minus 6 into x plus h whole square, and we got minus 6 into x squared plus 2xh plus h square, okay? So I'm just going to multiply with 12xh minus 6h square, okay? So this is the value of x plus h, all right? Now we have to substitute the function into the equation. That is, we have like f of x plus h minus f of x, that is equals to minus x squared minus 12xh minus 6h squared minus into minus 6x squared, okay? So we have minus 6x squared plus 12xh, sorry, this is not plus, this is minus. 6h squared plus 6x squared, okay? This value cut down by this and we have minus 12xh minus 6h squared, okay? So this is the value of this function. And now we have to divide this term into with h. We have an f into x plus h minus f of x divided by h, okay? This is equals to minus 12xh minus 6h squared, okay? And this is divided by h, okay? So just put the limit, which is h approaches to 0, okay? H approaches to 0. I'm just writing the whole function. And over here, when you say that the limit h approaches to 0, we have minus 12xh minus 6h squared by h, okay? If you can see that, if I take h common from this term, okay? Limit h approaches to 0, and I can write it be like that, minus 12x minus 6h, okay? So by putting the values, so we have, okay? So the function f prime of x equals to minus 12x, okay? So this is the required answer for this question. Now move towards the 8.3.2, okay? So write down how you will restrict the domain f such that f inverse is a function. So for a function to have the inverse, that also a function, so the original function must be 1 to 1, meaning it must pass the horizontal line test, okay? So f of x equals to minus 6x squared is a parabola. It fails the horizontal line test. So how we restrict the domain to make it 1 and 1, okay? So as you can say this, since we say that a function f of x equals to minus 6x squared is a parabola with turning point is parabola with turning point 0, 0 and opens downward. We must restrict the domain to one side of the turning point. Restrict the domain to one side of the turning. So we can choose that x greater or equals to 0 or x less or equals to 0. So the standard restriction is standard restriction is x greater or equals to 0. Okay, so that's right, because the restriction, the domain of x greater or equals to 0. Okay, so that means that x belongs to 0 to infinity in open form. Okay, so the problem asks for the equation of f inverse for f inverse of x less or equals to 0. Okay, so this is the required answer for this question. So the next part of this question is 8.3.3. So determine the equation of f inverse for f inverse of x less or equals to 0. Okay, so write your answer in the form of y. Okay, so we have the function y that is given that y equals to minus 6x squared. So I'm just converting it minus 6x squared. I'm just writing the function f of x with y. Okay, so swap x and y in this. Okay, so we have to swap x and y. We have minus 6y squared. Okay, so solve for y. We have to solve this equation for y. So we have a y squared equals to x by 6. Okay, now we're taking the square root on both sides. We got y equals to plus minus square root of minus x by 6. So we need to state the domain f prime f inverse, which is the range of f, since f of x equals to minus 6x squared with x less or equals to 0. Okay, x less or equals to 0. So we can say that function f of x less or equals to 0. So the domain of f inverse, the domain of f of inverse is x less or equals to 0. Okay, so this is the required answer for this question.
The next question is question number 9. A is the coordinate of A is 1 and 9, and B, the coordinate of B is 5 by 2 and 8 are turning points of the graph F below, and C is the y-intercept of F. Okay, this is the B point, this is the A point, and this is the C point we have. So what is the first question of 9? Question number 9 is 9.1. For which values of x is f decreasing? We have to find out. Okay, So a function f is decreasing when its gradient f prime of x is negative. Okay, we write it with a function f is decreasing when its gradient f prime of x is negative. Okay, so on the graph, this happens between the local maximum and local minimum. So we have to find out the value of x for two turning points A and B, alright? So the local maximum is at A, the local maximum is at A point, which is we have 1 and 9. So x equals to 1, okay? So the local minimum is at the local minimum is at B, which is we have 5 by 2 and 8, okay? So here we have x equals to 5 by 2. So the function is decreasing in the interval between these two x values, okay? So therefore f, so how we can write? Therefore f is decreasing and we say that for 1 less than x less than 5 by 2, alright? So the derivative of f prime of x is negative only when x equals to 1 and x equals to 2.5, or you can say that 2 point, sorry, 5 by 2, okay? This is the required answer for this question. So the next is we have 9.2. Write down the x-intercept of f prime, the derivative of f, okay? So the x-intercept of the derivative f prime of x are the values of x where f prime of x, addition of this question, okay, where f prime of x equals to 0. In terms of the original function f of x, we, what are these points represents? So the points where f prime of x are, f prime of x equals to 0 are the turning points, are the turning points, okay, of f of x, all right? Where we can say that where which are A and B. So now we only need the x coordinate. So the x intercept of f prime, the x intercept of the x intercept of f prime are x equals to 1 and x equals to 5 by 2. Okay, that's the fundamental relationship between a function and its derivative. So the critical points of f corresponds to the roots of f prime. All right. So this is the required answer for 9.2. 2. Okay. Now the next question is 9.3. For which values of x will f be concave up? Okay. So let's solve this question. Okay. So the concavity is determined by the second derivative. Okay. So the function is concave up when you say that the second derivative f double prime of x is greater than 0. Okay. So for a cubic function, the change in concavity happens at the point of inflection, which is exactly midway between the local point, local maximum and local minimum. So let's find out the x coordinate of the point of inflection. Okay. So the x coordinate of the point of inflection, the x coordinate of point of inflection, we say that x inflection, okay, is the average of the x coordinates, x coordinate of the turning point. Okay, so we have write it like that. X inflection, that is equals to xa plus xb divided by 2. We have 1 plus 5 by 2 by 2. Alright, so you can write it like that, 2 by 2 plus 5 by 2 by 2, and that is equals to 7 by 2 by 2, and we have 7 by 4. Okay, so the point of inflection is at x equals to 7 by 4. Now look at the shape of the graph. Before the point of inflection, the curve is opening downward. Okay, and after the point of inflection, what do you say about that? Okay, so the graph is concave up after the point of inflection, therefore f is concave up. Okay, for x is greater than 7 by 4. All right, so this is the required answer for this question. Now move toward the next question. So the next question is 9.4. Determine the value of k for which x y equals to f of x plus k will have 3 positive x intercepts. Okay, so the equation of y is equals to f of x plus k has x intercept where f of x plus k equals to 0, which is equivalent to f of x equals to minus k. The question is asking for the vertical shift k that makes the horizontal line y equals to minus k intersects f of x at 3 distinct points, and all those intersection points must have x greater than 0. So condition for 3 distinct real roots, the line y equals to minus k must pass between the local minimum y is equals to 8 and the local maximum y is equals to 9. Okay, and condition for 3 positive roots, since y-intercept c for x equals to 0, f of 0 is 7. And so we have to do for 3 distinct real roots the line, okay, for 3 distinct real roots, the line y equals to minus k must be between y minimum and y maximum. Okay, so we say that y minimum less than minus k less than y maximum. Okay, so this is what we say, that 8 less than minus k less than 9. To solve for k, multiply the inequality by minus 1 and reverse the direction of the inequality, okay? Sign. So we have to multiply this minus 8 less than k less than minus 9. So you can write minus 9, sorry, when you write it like that, when we write minus, multiply with minus 1, we have this is like that, okay? Now we say that minus k, minus 9 less than k, and this is less than minus 8, okay? So also the three positive roots conditions suggest a deeper analysis might be needed, okay? So we have, this is the correct range between minus 9 to minus 8, okay? So this is the required answer for this question. Now, the next question is question number 10. A cyclist rode from town P and stopped at town T. The speed in kilometer per hour at which the cyclist rode is represented by the equation s prime of t is equals to minus t square plus 18t. Okay, we have a note from this question. Speed is the rate of change in distance with respect to time, as you know that, okay? So the 10.1 is that calculate the maximum speed that the cyclist reached on this ride. Okay, let's solve this question. So we have to find out the maximum speed. We need to find the critical parts of the speed function as prime of t. This is done by finding the derivative of the speed function, which is acceleration, and setting it equals to 0. So let v of t equals to s prime of t. Let's suppose v of t equals to s prime of t, okay? So what is v of t? So we have to find out the v of t is, v of t is equals to minus 3t squared plus 18t, okay? So if you find out the derivative of this function, v prime of t equals to minus 3 into 2t, the derivative we use over here, the product rule, okay, plus 18, all right? So we have over here v prime of t equals to minus 6t plus 18, okay? So set the acceleration equals to 0 to find the time of maximum speed, okay? So it is equals to 0 we for acceleration set v prime of t equals to 0, okay? 60 plus 18. And now you said 60 equals to 18. And we have t equals to 3 hours. Okay. This is our time. So we have to find out next the speed value, maximum speed value. Okay. So maximum speed that is equal to s prime into 3. We have minus 3 into 3 square plus 18 into 3. Okay. So we have minus 3 into 9 plus 54. All right. So we just go and simplify the equation. 9 multiplied 3, which is becomes, we have um, minus 27 plus 54, and we got the value is 27. S prime 3 of 3, S prime of 3 is equals to 27. This the maximum speed reached was 27 kilometer per hour. Okay. So this is the required answer that we need to find out in this question. Okay. So let's move to the next question, which is we have, we have um, 10.2. Okay. In 10.2, we have to calculate the distance between town P and town T. Okay. So the distance between P and T is the total distance covered when the cyclist stops at T. Okay. So stopping means the speed is 0. First find the time when the cyclist stops, and by sitting as prime of T equals to 0. Right? Because we have to calculate the speed. All right. So I'm just writing that speed equals to s prime of t, we have equals to 0. Okay. So minus t square plus 18t equals to 0. And we have factor out minus 3t is common. We have t plus 6 equals to 0. And now you have, here we have two solutions, which is t equals to 0 and t equals to minus 6. Oh, sorry, t equals to positive 6. So the cyclist stops at town when t equals to 6 hours. Okay. Because t is equal to 0 at the start of the ride. Okay. And when the cyclist stops at town t, where we have the after 6 hours. Okay. So that's the duration of the trip. Now to find the distance as prime of t, you must integrate the speed function, which is s prime of t. Okay, remember that s of 0 is equals to 0. Starting distance is 0. So we have s of t equals to integrate s prime of t into dt. Okay, so s prime of t we have minus t square plus 18t. Okay, dt. So you just have to write the s So after integration, we have s of t that is equals to minus t square plus 1, sorry, plus 1 by 3 plus 18, 18t 1 plus 1 because the power of t already we have the 1 plus 1 by 2 plus t. So we have minus t cubed by 3 plus 18 t squared by 2 plus t. Okay, so this is cut by this and this cut by this. So we have minus t cubed plus 9t squared plus t s of t. Okay, since the distance at t equals to 0 is 0. So s of 0 is equals to 0, the constant t must be 0, alright? So we have s of t, since at distance at t equals to 0, s of 0 equals to 0. So we have s of t equals to minus t cubed plus 9 t squared, okay? So finally, we have to calculate the distance between town P and town T by evaluating S of T at the stopping time T equals to 6 hours. So the distance we have is distance is S of 6, which is equal to minus into 6 cube plus 9 into 6 square, and we have minus 216 plus 9 into 36, that is equal to minus 216 plus 324 equals to 108. This is S of 6. So the distance between town P and town T is 108 kilometer. Okay, and this is the required answer for this question. So the next question is question number 11. A certain number of the learners are sitting for examination in the mathematics, tourism, and geography. All these learners sit for at least 10, one of these examinations. The total number of learners who sit for the mathematics M is 22. The total numbers of learners sitting for tourism T is 16. And the total number of learners sitting for geography G is 18. 5 learners sit for mathematics and tourism, but not geography, okay? And 4 learners sit for the mathematics and geography, but not tourism. 3 learners sit for tourism and geography, but not mathematics. And 6 learners sit for only tourism. So the question is 11.1. Draw a Venn diagram to repeat all the learners sitting for this examination. Okay, so we have to draw the Venn diagram. So since the total numbers of the learner is not explicitly given, but all the students sit for the least one exam. So let's use the given information to find the number in the intersection of all three sets. Okay, so we have to make it be like that. We have x x equals to n m intersection of t intersection of g. Okay, so we know that the overlaps of two sets only are n into m intersection t only equals to 5, and n m intersection g is equals to 4, and n t intersection of g is equals to 3. So I will set up the calculations to find the x. Okay, so n of m is n of m, which is equals to 22, n of t equals to 16, and n of g equals to 18. Okay, so n, the first point we have make n of m only, which is 22 minus into 5 plus 4 plus x, that is equals to 13 minus x. Okay, and the 2 is n into t only. Okay, for this is we have 16 minus into 5 plus 3 plus x. Okay, and we have make it 8 minus x, and for 3 we have n into geography on. So we have 18 minus into 4 plus 3 plus x, and that is equals to 11 minus x. Okay, okay. So the total implies is 40. So we have to make the Venn diagram, right, on this. So how we draw this? Okay. So we have to draw with x equals to 2. We can now finalize all numbers for the diagram. So we have m intersection of t intersection of g equals to 2m intersection of t, only we have 5, and m intersection of g equals to 4, t intersection of g equals to 3, m equals to 13 minus 2, which is 11, and t only equals to 8 minus 2, which is 6, and g equals to 9. Okay, so let's draw the Venn diagram. We have now one circle, another circle over there, okay, and another circle over there. So this is M, this is T, and this is G. So we have enough 5. We have enough 5 over here, and because we have the intersection of M and T, 2 over there, and 11, 6, 6, and 3, 9, 4. You just see this section, and you just have to draw the Venn diagram. Okay, 4. Okay, this is how we can draw the intersection of all the questions. Okay, so this is the question that we need to find out in this question. Okay, now the next question is 10.2. Sorry, 11.2. Calculate the probability that a learner choose at random will sit for examination in at least two of the subject. Okay. So at least two subjects means that the learner sits for exactly two subjects or three subjects. These are the learners in the overlapping regions. So what is the total count for these regions? So n at least two, n at least for two, we say that n into m intersection t only plus n into m intersection g only. Okay, plus n into t intersection g only plus n into m intersection t intersection g. Okay, so this is equals to 5 plus 4 plus 3 plus 2 equals to 14. Okay, so the total number of learners is 40, and we have p is equals to 14 by 40. This is equals to 7 by 20, which is equals to 0.35. So the probability is 0.35. Okay. And this is the required thing that we have to find out in this question. Okay. So let's move to the next question, which is about 11.3. Determine if the event sitting um, for examination in mathematics and sitting for the examination in tourism are independent. Support your answer with a necessary calculation. Okay, so let's solve this question. So for two events M and T to be independent, the multiplication rule must hold true. So P of M multiply with P of T, that is equals to P into M intersection of T. All right. So let's calculate the three probabilities needed. First probability is P of M and P of T. Okay. P of M and P of T. Okay. So we have a P of M that is equals to N into M by total. We have 22 by 40 that is equals to 0.55. Okay. So P of T that is equals to N of T, which is equals to total 16 by 40, which is equals to 0.040. Okay. So we have to calculate P of M intersection of T. Okay. So this is equals to we have P P of M intersection of T. This is equal to uh, sorry, PM intersection of T, and this is we have equals to N into M intersection of T only, okay, plus N into M intersection of T intersection of G. And this is equals to 5 plus 2 equals to 7. All right. So we have M intersection of T, which is P equals to 7 by 40, and that is equal to 0.175. And check for independency, we have P of M multiplied with P of T, that is equals to 0.55 multiplied 0.40 equals to 0.22. Okay. So the events M and T, this is not equals to 0.22, is not equals to 0.17. The events M and T are not independent. Okay. So this is the required answer for this question. So this is the last question of this paper, question number 12. A company generates 4 track record using 26 letters of the alphabet and 10 digits from 0 to 9. The code is in the form of letter, digit, letter, digit. Okay. So 12.1 is that determine how many different codes can be formed if letters and digits may be repeated. Okay. So with 26 letters and 10 digits 0 to 9 and with repetition allowed, how many tries are there for each of the 4 positions? So position 1 we have is P of 1 is letters, okay? That is 26 options. And for P2 we have a digit, all right? So we for digit we have 10 options. Okay, and position 3 we have 26 positions. P3 again letter, we have 26 options. And for P4 digit, again we have 10 options. Okay, for it. So the total code, which is 26 multiplied by 10, 26 multiplied by 10, and we got 67, 600 codes. Okay, so this is the basic principle, counting principle, right? So this is the required answer that we have to find out in this question. Okay, so the next question is 12.2. Okay, determine how many different chords can be formed if the letters D, F, I, Q, U, and V may not be used. Okay, we did have used code letters. The code may not start with W or Z. Letters or digits may not be repeated. The code ends with an odd digit. Okay, this is very tricky questions. We can say that and be careful about that. Okay, so I will start with the list option that D. We say that D2 as we say that numbers. Okay, so D2 is the odd option. D2 as it has the odd digit restriction and then move to the first position L1 due to its letter restriction, okay? Digit and letter. So we say that D2, we say odd digit. This is equals to 5 options. And this is we have 1, 3, 5, 7, 9. And L1 is the first letter. And we have the 20 variable letters. And we say that 20 minus 2, we say that 18 options we have left, okay, in this. And the D1 is again second digit. This is equals to 10 total digits. Okay. And we have D2 used and 1. And repetition is not allowed. So we say that the 10 minus 1 is equals to 9 options we have in. Okay. So the last one is L2. We say that the third letter. Okay. So 20 available letters we have. Okay. So we have L1 used and 1. And repetition is not allowed. So 20 minus 1 is also we have 19. 20 minus 1 is also we have 19 options. So the total we have is code. We have is 18 multiply 9 multiply 19 multiply by 5 and we got 15,390. Okay. So this is the required answer for this question. Okay. The next question is 12.3, last question of this question number 12. We have to calculate the percentage increases in the number of the different codes formed in question 12.2. If the company allowed the letters D, F, I, Q, U, and V to be used. So the company removes the restrictions on the six forbidden letters, but all the other restrictions from 12.2 remain. No repetition, no W by Z in L1, D2 must be used. This means we now have 26 available letters instead of 20. We calculate the new total numbers of the code. Okay. So new numbers of the code is new numbers of code. Okay. So the first point is D2, odd digit. Okay. We have 5 options. Then L1 is the first letter. We have 26 total, and exclude W and Z. We have 26 minus 2, that's equals to 24. Okay. The third option is D1, which is the second letter. We have 9 options, no change, okay, in this. And we have the last one is L2, which is third letter, okay, which is we have 26 total. And L1 is used for, so we say that 26 minus 1 is 25 option. Now the new total chord, which is equals to 24 multiplied by 9 multiplied by 25 multiplied by 5. 27,000. Okay. So the percentage increases is new total minus old total divided by old total. Okay. So as you can see that 27,000 minus 15,390 divided by 15,390 multiplied by 100 percentage. Okay, this is also multiplied by 100. Okay, so we have to subtract them and then divide it, and then we have do the division with. Okay, so let's do it. So we have the percentage increases is 11, 6, 10 divided by 15, 3, 15, 390. 390 multiplied by 100, and that is equals to, we have 0.75. When you are doing the division and multiplication, 0.754 754 3 8, and then multiply with 100, and the answer is 75. After doing the multiplication of 75.438%. And this is the required answer for this question, that um, the possible course by um, that the removal of the letter restriction increases the number of possible codes by 75%, 75.44%. Okay, so this is the required answer for this question. Thank you.